Hi everybody. Today we're going to start Unit 6 actually, and we're going to just do some matrices. I know you can already do this, and a lot of you have done it in ALEKS. You did it in Algebra 2. We're just going to go through it, just end up the year with something that's pretty simple and something that you will see again. You'll see it on the ACT. You'll see it if you take any kind of linear algebra class in college. It's obviously a powerful tool to do solve a lot of equations all at once, and we'll get into all that. But today we're just going to get into the setup, some names, some definitions. There's a whole problem here, story problem here about two people that have a business making cutting boards, and so that's what these styles are to the right. They're different types of wood, and so in order to create a story problem, you have to be able to make a matrix out of that story problem. So I know you can do things with matrices, but it's really the story problems that we're going to deal with. So when you read the problem, it says style 1 uses 4 strips of walnut, 3 strips of maple, and 2 strips of cherry. And then style 2 doesn't mention the maple, or the walnut rather. It uses 5 strips of maple and 4 strips of cherry. 3 is 8 for walnut and 5 for maple, and doesn't mention cherry, so that would get a 0. So you can see that having these labels on the sides and across the top, very, very helpful. However, when you do the arithmetic, those labels have to be removed, and when you put them in the calculator, their labels are not something you want, so you have to really pay attention to what each thing means. So we're going to make this into a matrix, and a matrix is just a rectangular arrangement of numbers. You do need to use these types of brackets around your matrix, please. And then you'll also see that in the calculator as well. And make sure your answers have those symbols around there. The questions will as well. So if we're going to call this matrix S, your matrix gets a capital letter name. It will on the calculator as well. So make sure you pay attention to which one you're using. And then to turn this out into a matrix, obviously it's not a big stretch, but the idea is that your numbers inside the matrix are as simple as possible. You don't want a lot of extra numbers after the decimal point. For example, like $2, you would never write it like that. You would just write it as 2. Now, when you go to name a matrix, besides the capital letter, you have to also name it by its dimensions. This is an important step in the calculator. It is the first step in the calculator when you go to use that. And for the dimensions, it goes like this. It goes row by column. So the row comes first, so you count down first, and then the columns are across. So for example, down 3, this is a 3 by 3 matrix. And we'll go through, obviously it's hard to mess that one up. We'll go through and I'll show you some others that are maybe you don't know if it's a 2 by 4 or 4 by 2. Now each entry or each part of this matrix is called an entry, and those are also numbered. So the dimension obviously is 3 by 3. What's the value of the element S31? Well, S tells you the name of the matrix to look at, which we only have one. 31 says to go down 3. 1, 2, 3, and over to the first one. I destroyed that 8, but that is what it is, just to go over the first one. Don't call that 0 and call this the first one. That's not the first one. 8 is the first one, so that is an 8. I did skip the next page of the book. It's more about the story problem and setting up the story problem. Clearly, there's not going to be a lot of in-depth applications with these matrices since we're just online. It's really going to be about the arithmetic. So when you go to add or subtract, and I know you've done this, you've done it probably very recently in ALEKS, I've seen that. It's like they get superimposed, one on top of the other. This is a 2 by 2 matrix, and so is this one. It's also a 2 by 2 matrix. So since all of the elements match up, like the upper left-hand corner goes with the upper left-hand corner, since they are the same size, you can add the corresponding parts together. So 10 plus 6, 5 plus 7 goes up here. Then 0 plus a negative 8. Signs matter. Make sure you don't drop out your sign thinking that you're trying to make your matrix simple. The signs mean things. And then that's a 4. Now for part B, this is a 2 by 3. This one is a 2 by 2. This one is not possible. When we get to the calculator, and we'll do the calculator tomorrow just because today is so easy, it's almost faster to not use the calculator. I'll post a video using the calculator tomorrow. Your calculator calls this a dimension mismatch. And all that means is the dimensions make it so that you can't perform the operation. In this case, adding. It's possible that maybe the dimensions means you can't multiply as well. Now, when you subtract, you always want to add the opposite, so kind of a faster way is to go through and change all the signs on the second matrix. And then you can add these up, because this is a 3 by 2. This is also a 3 by 2, so the dimensions match, so this can be added together. Make sure your matrix is neat. And when you numbers to add up to 0, 0 is a number there, so 6 minus 6, that's 0. And 10 plus 3, that's a positive 13 in that corner. So what must be true about the rows and columns of two matrices in order to add or subtract? They have to have the same. So the dimensions absolutely have to match in order to be able to add or subtract. Now, just some tiny details that they'll try to trick you with, and maybe you've already seen this, is just some names. The identity matrix for addition. Identity means you don't change its addition. So like 5 plus 0 equals 5. So basically the question is, what do you add in order to not change the identity of a number? Well, you would add 0. So that's pretty easy to do. But in matrix addition, in order to add a matrix to a matrix, let's say we have 1, 2, 3, 4. You can't just add 0. It doesn't work like that. You have to add a matrix of that same size with all of the elements being 0. And then you would get that exact same matrix again. So you do have to make sure that you have to have matrix in there. Now, an additive inverse, this is a fancy way of saying opposite. And the best way to make an opposite is to multiply by -1. Not to really do anything with add or subtracting. And multiplying by -1 allows you to change all the signs. So that's how we can make the additive inverse or the opposite. So when you multiply by a number, that's called a scalar multiplication. And I'm just going to make up a matrix. They want us to use matrix A, or S rather, so I'm going to just call matrix A. And let's just make matrix A 2, 0, -1, 3. Then they might tell you to do something like 4A. Well, 4A, that looks like multiplication. It is multiplication. And basically they're saying take the number 4 and multiply it through your entire matrix. It is simply distributive property. So you could do this in the calculator. I would not suggest it. I do think it's faster to just do it yourself. But then 4 times 3. And then each number stays in its original position. So that's how you multiply a number by a scalar. Your scalar can be anything. It could be -1. Your scalar could be 1/2. The scalar is not a matrix. The scalar is just a value. You could even have a radical. But we probably won't get anything that crazy just because of the time that we have left. So make sure you try your assignment. It is pretty fast. And I'll post the answers for that. Hope you're having a good day.